I don't have a paper in front of me. I don't know where my paper is. Oh, 9 or 18?
I thought it was wrong.
Okay, let me write both of them. Is there anything else while I'm writing down problems 9 and 18? Anything else? Is that it? 9, 14, 18? 17. 17. That's not it. No. Okay, hold on. You don't get that many. What did you say, Madison? 15. Can you give me that one? Oh, you had the first one hooked to it. Let me say it one more time. Sorry, thank you. This one, Madison. All right. We have a lot then. Let's go. This is not from the homework sheet. This is from the classwork stuff. All right, let's look at number 9 first. That looks like that comes first. Ooh, y'all got nice and quiet. Ready to learn, Brian says. Everything's factored, so I don't need to factor anymore. She said, did it used to do that? Oh, it didn't used to do that. All right. So everything's factored completely. What's my LCD? X minus 3. That's exactly right. This is the only one that needs anything. So I end up with 2 times x minus 3 minus, here's where you have to be careful because it's minus everything in that second fraction over x minus 3. So I'm going to have to distribute that negative through. So I end up with 2x minus 6 minus x minus 1 over x minus 3. Oh, I didn't multiply. Oh, I should mark those x's out, shouldn't I? Why? Don't kill a kitten. So these plus or minuses are not in parentheses. It would, yeah. All right. What? Oh, already got them. 14. I've got 4. I'm gonna look at top first. So 4 over 1 minus 1 over k, which is the LCD. Is that what y'all were saying, or were y'all saying okay? 4k minus 1 over k. Now the bottom. 8 over k minus 2, welcome, over k squared. What's the LCD? Close. K squared, right. But this one's got 2 k's. This one's our k. You see what I'm saying? So this one needs another k. Yeah. Yeah, give it a k. Yeah. Okay, so I got 8k minus 2 over k squared. Can I take a k out? No. You could take a 2 out of the top and have 4k minus 1, but you can't mark a k out. All right, put them together. Top times, flip the bottom. And make it all one fraction. I have a 4k minus 1. I have a k. It leaves me with k over 2. That came out nice and pretty. That's okay. You need a white one. Those white erasers, have you tried them? They work really well. They work better than the pink ones. 17. Nope, 15. 15, let's do top. 4m over 5n plus n squared over 10m squared. What's the LCD? 10. You don't need the other 5. Oh, it's on the classwork. Sorry, this is the one on the classwork. All right, look. You can write this as 5 times 2, so there's already a 5 in it. I don't need that again, but I do need the 2. Because remember, you got to be able to have the, what's the LCD of 5 and 10? 10. You wouldn't say 50, right? Because that's a common denominator, but it's not the least common denominator. So I want the least common denominator. So first look at the coefficients and then look at the variables. So the LCD would be 10m squared n. Exactly. So 2m squared, 2m squared. This one has the 10, it has the m squared, it just needs an n. So I end up with 8m cubed plus n cubed over, ooh, I see something. What do you see? Do you see what I see? Close, but they're not squares. Cubes. They're both cubes. Is it? I wrote down plus. Is it subtraction? Go ahead, Stella. Who's saying it? Somebody's saying it over. Is that you, Stella? Say it. Yeah. Come on, Stella. You can do it. 2. Yes, so that's a sum of 2 cubes. That's little parenthesis, big parenthesis. Same change plus on the signs. What times itself 3 times gives you 8m cubed? What times itself 3 times gives you n cubed? And then it's square the first for the first spot, square the last for the last spot, and put them together in the middle. The general form is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. It's the hardest to remember. But it's the same as the difference. They're the same. Sum or difference of cubes. How about bottom? What's the LCD on the bottom? Ah.
No, N.
2mn squared. So what do I need on the first one? 2m. How about this one? So I end up with 2m plus n over 2mn squared. Now let's put them together. Great, googly moogly. All right, top 2m plus n, 4m squared minus 2mn plus n squared over, I'm just rewriting the top. Now I'm going to flip that bottom over, 2mn squared over 2m plus n. Whew. Yep. Anything else? This and this with a 5, and then one of the m's, one of the n's. So up top, I have 4m squared minus 2mn plus n squared. But I still got that n that's up there, right? I still got 1. Over 5m. That was fun.
I'm still like our homework isn't great over X. We didn't have to submit the whole package, did we?
No, just not. It's okay. It's a good practice one.
So wait, what was the
Wait.
Sorry.
That's okay. Right there.
I accidentally
Want me to kind of scroll out? Yeah.
Everyone hates Scotty on the You don't like that? I posted Even Kizzy, she's beside me, she's like a real.
The Aggiest song we sing. Just think about it. Just think. Okay. All right. Let's look at number 17. Let me come. Brian, what is going so violent? LCD! X. So I need to give this one an X. I end up with x cubed plus 1 over x. The top of that is a close sum of cubes, but so it ends up being x plus 1 times x squared close minus x plus 1. All right, there's top.
I didn't even notice it.
Bottom.
X plus 1.
Oh, it's already simplified, right?
I just like wrote them. I don't think so.
There's nothing else I can do with the bottom. It's already fully factored single fraction.
I just wrote them out.
So
X plus 1, X minus 1.
you could if you wanted to. If you want to do x plus 1, x plus 1. Yeah, no. Yeah. Yeah.
On the homework,
I'm trying to figure out what time this is.
wait, is it 7?
I'm trying to figure out what time this is.
That's not fair.
It
What number is it?
We're on number 17. Where is my show?
Oh, wait.
It could be.
For the top. Okay.
All right, let's put them together.
I see you put down.
Top. Flip the bottom. Now, and if you wrote it this way, that's fine too. Might be a little easier to see that way. And then an x, that's right. So I end up with 4 times x squared minus x plus 1 over x plus 1.
Okay. Now I put the 4 into the thing.
Don't, you want it factored completely. It's not wrong if you did, but you want it factored completely. You're undoing work you've already done if you did that. Brooklyn, what was yours?
Like when you cancel out like the x out of 4x, like
Yes.
what do you do about it? Like on the previous problem with this time, with the 5 and the 10.
Okay, so that simplified because 10 divided by 5. It's just like simplifying a fraction. This is like 4 over 1, which doesn't simplify anymore. All right, last one. 18. What did it say? Find the area? So let's just, okay. Yeah. All right, let's look at this one first, and let's simplify it first. So we'll call this length. So the length, this will be width. I'm very original. Okay, so the length is 1 over x minus 4 over x squared over 4 times x minus 4 squared. So let's just work with it and simplify it a little bit. Up top, 1 over, yeah. Yes, yes, that's exactly what you would do. Yes, yes. LCD here. Squared, so this needs a x. So I get 1x minus 4 over x squared. This one's already simplified, right? So I'm just going to go ahead and put them together. So top, yep. Yes, yes.
Unless it was like
Ah.
yeah.
Right. All right, looks like an x minus 4 cancels here and here. So I know that length is going to equal 1 over 4x squared times x minus 4. Do we all agree? Yeah. All right, that's just the length. Now look at the width. Hold on, let me finish copying this.
I have 2x.
I'm going to have to come over here. I'm out of room. All right, so width is take out 2x, and I'm left with x squared. Yeah, I'm listening.
I was just saying that's not true.
Right.
Oh, okay.
Absolutely. And I get minus 4 plus 4. That's right. Which means my width is 2x, x minus 4. Now you multiply them together because area of the rectangle is length times width, right? So my length was 1 over 4x squared times x minus 4. My width is 2x times x minus 4. And since this is a fraction, I'm just going to put that over 1 so that it is a fraction also. And I'm going to make it one big fraction because I'm multiplying. And because I fully factored length and width before I started, it's still fully factored, which means I can just, I'm not dividing so I don't flip. I know what you're saying. I'm listening.
I got that, but then I simplified it to 1 over 2x.
That's right.
But I changed my word. I didn't know what to do with it. minus 4 squared, and that was but the whole time
So just remember that just means written 2 times.
So that means that it's simplified. I was
Right.
like trying to put it into like I was trying to FOIL them, and I was like, no.
That might not be the hardest one. Number 1.
I thought FOIL.
Okay, you can't FOIL, and the reason you can't FOIL on this one is because there's no plus or minus inside here. That's a multiply. So instead, the only addition or subtraction operation I have is this very last one here. And since order of operations say multiply first, I'm going to handle that first. So really, I can drop these parentheses because multiplication is commutative, and I can multiply these in any order that I want. So negative 5 and 6 would be negative 30. When I multiply with the same base, I add the exponent, so I get x to the 5th. Y to the 0, so you get rid of it. Good job. So now these are like terms, which means I can combine them to negative 23x to the 5th. Remember your rules. If it's a negative exponent, where does it go? On the bottom. That's exactly right. If you're dividing, you subtract. If you multiply, you add. And if you are raising a power to a power, you multiply. 1 over 49. Yeah. What? No crumbs? No crumbs. Y'all ate! Because y'all got that one right. Oh. Yeah, that's it.
When there's like an exponent on the outside of
As long as you are only multiplying or dividing in the parentheses. Because if you end up with something like this, you would have to FOIL it. But if it was something like this, then yes, you would distribute. Yes, but I would probably distribute that through first, because if you look, you got a negative exponent in there, so one of them's going to be negative and one's positive. Yes. How about 5 through 8? Do you need one? I'm thinking y'all should be able to do those. Just remember, like on number 6, when you have something like this, that's a FOIL problem. Don't distribute. Yeah. They're FOIL problems, yeah. Number 5's not. Number 5 is just addition, subtraction, but yeah. How about 9 through 14? Do we remember how to factor? Even if it's something like 14? Quadratic form? Remember, you can use patterns on those, but they're mostly quadratic form or a pattern. If the leading coefficient's negative, you definitely want to factor out a negative before you start. Yeah. Yes. Remember, quadratic form means even first exponent. Half of that first exponent is the middle exponent, and then the last one is a constant. And biggest exponent down. Yeah. If this happens and you get in this form, you can factor like normal. What multiplies to negative 20n to the 4th but adds to 1n squared? 5n squared and negative 4n squared.
Wait, what?
This is y'all don't remember quadratic form? If the first exponent is even, the middle exponent is half of the first, and then the last is a constant, then you can just factor like normal. You can group it. So you got the negative 1 outside, then I got n to the 4th plus 5n squared minus 4n squared minus 20, and now I can just slash. What's the GCF of n to the 4th and 5n squared? You could use the shortcut on this one. You would just have to know that it was squared, though. I was just showing you long because it always works. It leaves you with n squared plus 5. Take out a 4, n squared plus 5. But for this one, I'm not done after I factor. Plus 5. Because I can break down. That's exactly right. That one breaks down again. Good job. Good job, Kristen.